Welcome, everybody. My name is Aaron Ballman, and I'm going to give a little bit of an update on what's going on with Clang and the Clang community since the last time I gave this talk, which was October of 2024. So this is basically what's been going on over the past year. And I would like to give a big thank you to Vlad Serebrennikov for his assistance with gathering a lot of the data that I have in this talk. I like graphs, you'll find that out. So diving right in, what kind of things have we been working on the C side of things is we've largely been working on C23 and C2Y support. So in Clang 20, we improved enumeration support. So now you can have the C23 feature allowing fixed underlying types like they had in C++, as well as enumerations that are of type long as opposed to of type int, which is an extension that everybody has supported for decades. In Clang 21, we worked on some of the C2Y features like count of, which allows you to determine what the extent of an array is. We also added another C++ feature for octoliterals, where you have 0O to prefix them like you used to have for 0x and 0b and that sort of thing. And another one of the Clang 21 features that we worked on was improved tag compatibility. This one's a little bit of an oddity. In C, your structure types, we don't have a one definition rule like C++ does. Instead, it's based off of type compatibility. And so the committee decided if you have two types that are compatible across translation units, surely they should also be compatible within the same translation unit, which means you could actually redefine structures in the same translation unit as long as all of the members are the same, the alignment's the same, and that sort of stuff. This turned out to be a little bit of a bug factory. I expect there's going to be a long tail of bugs on this one that we're going to be fixing for years to come, but it does mean that you can actually make better use of anonymous structures in your code, which is really interesting. And in Clang 22, we've been continuing on. We worked on named loops, which allows you to break from multiple nested loops. You can break to a label or you can continue to a label to make it more easy to determine what the control flow is. And one of the other things in Clang 22 that we're working on is the defer technical specification. So this is not actually a published TS yet. It's in the process of going through the publication process. But there's so much user interest in this feature because it basically brings to you the same kind of things that you had in C++ with RAII. This is more of a C feature of this where it doesn't have constructors and destructors. Instead, you're basically saying, I'd like to defer execution of this until the end of the scope. And then across all of the different Clang releases, the C committee's been working on this series of papers called Earthly Demons papers. Basically, there's undefined behavior that made sense 40 years ago, but it doesn't make sense anymore today. Nobody's used it as an extension point. It just didn't pan out. And so the C committee has basically been turning those things into constraint violations. So you get a diagnostic for it. And so across all of our the Clang 20, 21, and 22, that's one of the things we've been doing is removing those undefined behaviors. So in terms of where we are with completeness for C, the pie charts are showing you the data as of 2025. The text is telling you what the data was in 2024 when I pulled it. So we can kind of see how we've been progressing. C99 is exactly the same. We have done nothing with it for the last year. Not too much of a surprise. On the C11 side of things, we took that 21% unknowns and got rid of all of them. So now we know that we are 82% of the way done with C11. C23, similarly, we improved from 76% complete to 79% complete. That was mostly turning no's into yeses. And then C2Y, this one's a bit, take it with a grain of salt. C2Y isn't finalized. So what it was in 2024 is very different than what it is in 2025. But we have been continuing to progress it. And as of now, we're currently about 81% of the way done with C2Y. So on the C++ side of things, we've also been doing plenty of work there. In Clang 20, we worked on C++ 23's range lifetime extension and range-based for loops. This is a really nice feature in that it removes an undefined behavior that was really easy for people to run into with references. And so this just removes that entire class of failure modes, which is great. We've also been working on our constant expression support. So we added unknown pointers and references for constexpr, as well as constext replacement new. And then we also have been working on C++ 26 with its variadic friend support in Clang 20. And in Clang 21, we've continued the C++26 trend. We worked on structured bindings in packs. We worked on structured bindings in conditions, like in if statements. And then we also implemented the trivial relocatability traits for the libc++ side of things. This one is a little bit in flux. There's a C++ meeting happening next week, and they're going to be going through national body comment review on things, and there are comments about trivial relocatability. We implemented what the paper currently says, but if things change in the committee, we'll go ahead and figure out what to do with it from there. In Clang 22, we've largely been doing bug fixing. As is probably no surprise to anybody here, C++ is an incredibly complicated language to support. And so this is kind of a chance for us to take a little breather and try and fix up a bunch of bugs. It's not that we're not working on newer features or things like that. It's mostly just that this is the way it's shaken out. The two big things that I expect us to see us working on for Clang 22, though, from C++ is contracts and reflection. And again, these are going to be discussed at next week's C++ meeting, so things might change. But the good news is here is we have two different forks that have the experimental versions of these. And there are people from those forks that are working on bringing those upstream. So it's not going to be a big code dump. They're going to have to do the same thing that like CIR folks did with regards to bringing it in piecemeal. But we do have plans for supporting contracts and reflection. There is almost no chance those will be done for Clang 22, just so we're clear. These are multi-year efforts. These are big projects. So in terms of our C++ conformance, again, pie charts are showing you what's going on right now. Text is telling you what's going on in 2024. So on the C++20, we went from 92% complete to 95% complete. This was largely due to folks working on C++20 modules. That's basically the only thing we have left for completing C++20. And C++23 support improved a little bit from 89% to 91%. And then C++26, just like with C2Y, it's a moving target. It didn't become feature complete until fairly recently. So the fact that we were 83% complete before and 58% complete, that's just because more features have been added and they've been larger features. So it is something we are actively working on. So switching gears a little bit into defect reports. So these are basically bugs in the standard. And I don't have the pretty pie charts from 2024 for this, but I did spot check the data. And we're basically exactly the same in 2025 as we were in 2024. On the C side of things, we are 50% complete of implementing our defect reports. We have about 9% that we don't know whether we do or don't implement the defect report. And on the C++ side of things, we've got 21% complete for being done with the defect reports, but 54% is unknown. And so there is a lot of unknowns that we really need some assistance getting test cases written for to figure out whether we do or don't support the defect reports. And this is actually really critical for us to do because the standards committees assume we have all implemented every single defect report. So every new feature they add assumes every defect report has been fixed in every implementation. The good news here on the takeaway is if you look at the no's, it's 2% for C and 2% for C++. So there's not a whole lot of things where we've just said, no, we haven't done this and we don't expect to. So this is kind of our trend line as to how we've been doing with fixing defect reports. And you'll notice Clang 18, 19, and 20, we were doing really good. That was trending in exactly the right direction we wanted to see. Clang 21, it dropped off. And as of Clang 22, we haven't fixed a single defect report. So it's starting to look like in the future, we're going to be adding new defects as opposed to actually fixing any of them because that trend line is starting to go negative. We could really use help with regards to working on defect reports. It's not the most glamorous of things to work on, sometimes really frustrating, but it's really important work. So now a little bit about our community. I thought this was kind of interesting. I wanted to know when do we do our work? So the bottom is Monday, and then it goes Monday, Tuesday, Wednesday, all the way up through Saturday and Sunday on the very top. And one thing you'll notice on here is there's a dip somewhere. Can anybody guess where Christmas happened in 2024? Right around month 18. These are 4-week blocks, not actual months. But 2023 is actually on here as well. It's right around week 4. And that's why there's a little dip going on there. And I thought it was really interesting that there was such a stark difference between the two. So I dug into the data a little bit, and it looks like in 2023, we basically just did business as usual through most of December, and people took off kind of the week of Christmas. And in 2024, it seems that people just took all of December off, which is really interesting. But another thing that's kind of interesting about this is if you look at the weekend work, we don't do much on the weekends. We're a Monday through Friday kind of community, which is probably not much of a surprise to folks, but the weekend work is increasing over time. So the left-hand side of the graph is all narrower bands than the right-hand side of the graph. So we are starting to pick up steam basically across the board. We now have a dashboard, by the way, to help track this kind of data. There was an announcement on Discourse last week for a dashboard, Grafana dashboard showing this sort of data. So if you're interested in these things, we're starting to gather this more and have it more publicly available. So in terms of how long does it take to get pull requests closed? This is both merging pull requests as well as just closing them because we've decided we're abandoning that work. Most of it ends up being merges. But the top graph is showing us under a week versus over a week in terms of how long the PR stays open for. And the bottom graph is the same data, just showing it 1 day versus more than 1 day. And a really nice thing to notice about this is on the over a week line on that top graph, that trend line is going down, which is great. We want to see people being able to have good velocity on getting their PRs merged. But I am a little bit concerned about how rapidly the 1 day is rising. It's impossible to say exactly why that's happening. It could be because we're doing more for supply chain security, and so people are pushing up more trivial patches. It could be that we're doing more reviewing of one another's work and not doing a very good job of it. It could be more self-accepts. So this could be a demonstration of poor code review practice, but we don't have enough data or insight to know exactly why it is. It's mostly just something that we should pay attention to as we're gathering this sort of data. But the nice thing is the trend is really for closing stuff is going in the right direction. We seem to close most stuff between 1 day and 1 week, which is pretty good. This probably comes as very little surprise to anybody here, but who is doing the work? On GitHub, if you are listed as an LLVM member or a contributor, that's basically almost 100% of the people doing the work. But our first-time contributors are starting to pick up steam. We're starting to see more people do first-time contributions, which is great, because those are the folks that build up the future for our product, which is something we really need to do. But one thing that's a little worrying to me is when you look at the number of still open pull requests, the ones for first-time contributors, almost every one of their pull requests remains open indefinitely. They're not getting reviewed. And I think that what's happening here is because when you are a first-time contributor, you don't get to put anybody down as a reviewer on your PR. You're not allowed to via the UI, and no one is auto-added. And so it's really easy for a lot of the first-time contributors to have their PRs go under the radar because nobody's being added to them. So it's something we need to be more proactive about until we get better authorization on the GitHub side of things to be able to allow people to add their own reviewers or automatically add them for you. Not really worried about how the trend line is going straight up in the last couple months. That's basically just active work that people are still working on. That data makes a lot of sense. But there is an overall trend in that we are increasing the number of still open PRs over time. And this, to me, says we need more focus on dedicated reviewers. That's the bandwidth is the bottleneck within Clang a lot of times is getting code review attention and doing quality code reviews. So if you have the opportunity to help out with code reviews, please jump in. You don't have to be an expert. You could just come in and say, hey, this doesn't match the style guide. That's still helpful. So anything you'd like to do with helping out with code reviews would be fantastic. And then switching gears a little bit to our users. What language modes do our users use? Now, one caveat to this is this data is all gathered from SourceGraph. So it is skewed massively towards open source projects. We obviously don't have any insight into what people are doing with their proprietary code bases. And the other thing is we have no way to know what people are doing if they don't pass an STD flag, or they use, for example, from Visual Studio, C++ latest. We don't know what language mode those correspond to, so this data is kind of incomplete. But the really interesting thing to notice about this is 90% of C++ code is C++ 17 and earlier. 95% of C code is C11 and earlier. So this is demonstrating that we really need to make sure to keep existing code working. That is a very important thing for our users. That is not to say we should just ignore all the new language standards, though, because the baseline expectation of users is we're going to support every language standard. So we're going to have to do that work at some point. This is more just a reminder to folks that if it's going to take a little bit longer to land for a C++ 26 feature, that's fine. It's not going to get in anybody's hands for years anyways. And so don't sacrifice the quality of older language modes just to rush to get something out for a newer language mode. Because you'll notice, C++ 23, 2%, C23, 1%. The latest standards like C2Y and C++ 26 don't even have enough data to show up on the graph. So, what kind of things am I seeing people talking about online? This is gathered from places like Hacker News and hallway conversations and standards meetings and that sort of stuff. One thing that's really interesting is the defer TS has over 300 emojis on that pull request. I've never seen anything like this in the Clang community before. There's a lot of excitement around that feature, which is really interesting. But users are also still super excited about the security improvements that we work on. I still see a lot of people talking about how excited they are for bound safety. I'm seeing more conversations around lifetime safety. Sanitizers continue to be super popular. So work that we're doing to help users secure their code is still very much appreciated. And then, as I mentioned before, we do have people who are tire kicking the newer standards. So we have folks who are trying out C23 and C++ 23 and reporting issues to us. It's good for us to work on those, but by far, most folks are still stuck on old standards. C99 and C++11 are the lion's share of what people's code is. So within our own community, we are looking for some help with completing C++ 20 modules. This is something the modules maintainers have gone on discourse and asked for help with, and that help has not materialized. So this is the one thing that's holding us back from saying we're done with C++ 20 is modules. So if you're interested in language support, helping out with modules would be really fantastic. I hear there's a roundtable that's going to be going on today or tomorrow about modules. And so if you're interested in that, I would highly recommend going to the roundtable for it. We are continuing to work on new C++ features like contracts and reflection, but those require a massive amount of investment. Those are going to require lots of test cases, lots of documentation, and these are just really, really big features. And so these are things that I think our community is going to wind up investing a lot of effort in terms of code review. But the one thing that I saw over and over and over and over again, build times are terrible and documentation manages to be worse. And so this is something that really frustrates a lot of people, especially on the C++ side of things. The compile times for C++ have been going way up with every release of Clang. And so we really do need to start paying down some of that technical debt to keep our build times low enough to remain competitive. And we really need to work on our documentation story. Our docs are all over the place. There's a lot there that we could really use some help with working on. So if you're interested in getting started working on Clang, working on things like documentation is actually really a great way to get involved because it's pretty easy. It's very, I wouldn't say low effort, but it's pretty easy bar for you to clear in terms of getting your patch accepted. But it really has an outsized impact on our users. It may not seem that way, but it is something that our users would really appreciate. With that, thank you. I'm curious to hear what questions you might have.
This is just a minor question about the defer blocks. How does that interact with the attribute that I forget the name of that functionally acts as a deferred?
Sorry, I'm having a hard time hearing you all around.
Sorry. there's an attribute that does something similar to defer, and I'm
Oh.
just wondering how that's expected to interact.
Yes, so there is a cleanup attribute that exists, and defer is basically syntax around the cleanup attribute. In fact, if you look at the implementation of it, it is using the exact same machinery as the cleanup attribute does. So they will interact with one another, and it all just falls out naturally.
How do you feel about the sustainability of adopting the next 10, 20 years of C and C++ language features for Clang?
Oh boy. So I think that the committees almost think like we're waiting for something to do and twiddling our thumbs. And if they don't give us work, we're going to just all be out of a job. And so I am actually worried about the sustainability of new features, and especially as they become larger and larger. So like modules was huge, reflection and contracts are huge, concepts were huge. These sort of features in C++ anyways, those are really expensive and hard for us to maintain and support. But on the flip side of it is, there's nothing we can really do. The committee is going to do what the committee does, and the problem is once the committee goes and adds a feature, then people start doing conference talks about it, everybody starts getting excited, users start saying, why aren't you supporting it? And so we just have to bite the bullet. One way that we can help with this is if you join one of the standards committees. If you join the C committee or you join the C++ committee, you can then have your voice heard on the committee with regards to how expensive certain features are in terms of like their feature set and what the design of it is. And that's really the best way to have any sort of influence on this sort of thing is through the standards committees. But it kind of is one of those situations where it is what it is. But yeah, it's definitely a concern.
Aaron, thanks for the talk. Did I read it with the graph right that the PR turnaround time got improved this year?
Oops, let me back up a little bit. Yes, so this is data that's coming back from September of 2023 through to September of 2025. And yeah, the throughput has definitely improved on getting patches accepted.
Yeah, do you have insights what contributed to that?
I don't. It seems like it might be just growth of the community. And so we have more people submitting PRs, therefore we're accepting more PRs. But I don't have enough granularity in the data to really be able to dug into it that much.
Mm-hmm. Thank you, that's good to hear though.
Yeah. Well, if there's nothing else, thank you all very much for coming. Appreciate it.